Currently on the screen is a view of the deepening hurricane Irma. This is via the Cayman Hurricane Center, and here's Adam, who will be providing all the information.
Right, thank you very much, David, and thank you everyone for joining here. This is a special live streaming update on very dangerous hurricane Irma, a very powerful Category 5 hurricane heading towards the northern Lesser Antilles, the Leeward Islands. And this evening, I'm here joined with a wonderful panel here. I have obviously with me here David, I have Lee, I have Lucy, and I have Chris here with us. Everybody say hello.
Hello.
Yep,
Hello.
Yeah. Right, so let's get right into it. This is a very, very dangerous, potentially catastrophic Category 5 hurricane. It is, as I said, nearing the northern Leeward Islands, and weather conditions will deteriorate over the islands very, very soon. Give you the particulars on Irma. As of the 8 p.m. advisory, located at 17.2 north, 60.5 west, or about 85 miles east of Antigua. It is roaring with a maximum sustained winds of 185 miles per hour. Present movement is off towards the west at 15, with a deepening central pressure of now 916 millibars. This would make it one of the most dangerous hurricanes out there in the Atlantic. It ranks at the top 5 most powerful hurricanes in the Atlantic Basin. And as you can see on the screen there are some lists of the hurricane watches and warnings. There has been a bit of a change as well. The Meteorological Service of Cuba has issued hurricane watch for the provinces of Manzanares and eastward all the way to Guantanamo. But also, as you can see, the various list of hurricane warnings for the northern Leeward Islands, as well as hurricane watches and tropical storm warnings for areas of the southern Leeward Islands, and obviously the hurricane warnings for Puerto Rico and the Virgin Islands. This storm, again, very dangerous and could pose a serious issues to these islands here. Just want to quickly run through you the general forecast track. Not really looking too far ahead, and there's a lot of questions to be answered in the near future as well as in the medium to long term. But as you could see here, just before getting to that, as you can see, very tight, decent eye here with a very tight central dense overcast around our system. Very starting to become somewhat sort of annular, very rounded in shape. As you can see here, or maybe possibly see here, are parts of those islands here already starting to get those impacts in as we speak. So just going on here, here's the initial forecast track for the time being. This is over the next 3 days. And there's still quite a bit that can change with this over time, and we'll have to be watching it very closely. Again, with this, we also have ourselves the general wind field of the system, the watches and warnings that are in place for these areas here. And this is something that will have to be watched, especially not only for the areas in the watch warning areas, also areas such as Jamaica, the Cayman Islands, the rest of Cuba. Also, the state of Florida will need to keep an eye on it, as well as the rest of the Bahamas over time, as there are the potential for these areas to be further impacted by the system. At the present time, here is the tropical storm uh, wind probabilities for the area. And as you can see, it covers a very wide area because there's quite a bit of large area possibilities that can occur. And again, with the larger wind field too, that will also widen out. But again, a good portion of the islands here, you can't even see parts of the Greater Antilles, but here we go, Jamaica, Cayman Islands, Cuba, even up to Florida, Bahamas here. There's also the other area here, which I'll also mention a little bit later, which is Tropical Storm Jose, which also could potentially pose some threats to these same general areas here, potentially over the next few days. We'll have plenty of time to watch for that. And just to point out, to give you an idea on timeline of where we can see the arrival of tropical storm force winds, here's the most likely situation, the most likely timing for it. And as you can see here, the island will definitely be feeling that definitely through tonight into Wednesday. Areas of potentially the Bahamas and Hispaniola throughout Wednesday, Thursday. And then again, it gets a little bit tricky with the track depending on what it does. It could be Bahamas, it could be Cuba, it could be even down far south as Jamaica, the Cayman Islands. We'll have to wait and see how that plays out. But again, here are the timings for those areas here. In terms of any sort of impacts to the United States, again, that is several days out, and a lot can change. A lot could change. What we do think, however, is that this whole entire general area could be under the gun. So we'll have to watch. Again, there's no definitive say whether it'll be directly through Florida, east of Florida, west of Florida, you know, anywhere along here or up here. It's just way too early to determine that at this point in time. What I would mention, and again, I would caution when looking at this, I'll point out to you here, the few top best performing models and their ensemble runs. I'm going to show you some of them now. Here, you could see sort of not so well. I tried to get the best image I could, but here is the UK ensemble runs. And just to give you a clear picture, here is the continental United States. Here is Mexico, the Yucatan here, the island of Cuba here, Hispaniola here, Puerto Rico here, and the rest of the islands along here. And as you can see on the ensemble runs here, the UK Met, one of the better performing models here on this system, and it pretty much takes this thing through the northeastern Caribbean, and maybe impacts over Hispaniola, maybe south of there, and then impacts possibly Cuba, or passing south of there, or passing south of Cuba through Cuba, and of course into Florida. Again, the spread is wide, so I would caution, you know, anywhere within that, you know, is under, should keep a close eye. Again, there's nothing really urgent about this. You know, Governor Rick Scott did declare a state of emergency for Florida. However, I would caution the state of emergency is not for any immediate sort of effects, but rather as a measure to get the different agencies start getting going, start getting ready to prep for this system, shall it be an issue. Here is also another very well-performing model, and its ensembles. This is the European ensembles. Just to point out, I'm not going to show all of them here, but just to give you a general idea on the short term, short to medium term possibilities on tracks here. Just to give you an idea, again, through the Eastern Islands, potentially through portions of Hispaniola, through Cuba, potentially as far south as the northwestern Caribbean. And again, the spread is quite wide, going out past 72 hours. But again, you get the general idea that the islands in the Greater Antilles would be impacted next, and then possibly potential impacts to somewhere along the southeastern half. This area is also Tropical Storm Jose, and that's their probabilities on that for the time being. And not really going to get into too much with that just at this time. But this is just to show you that, you know, again, the Eastern Caribbean Islands impacts are now going through the next couple of days, with the central Greater Antilles and potentially the western Greater Antilles to get those impacts going forward. Another thing that I would want to mention is, well, what's steering this? How is this thing being steered around? And if Lucy could come in, you know, we were talking about earlier throughout the week how, you know, depending on how the high setup, how things were, that this could push potentially further south, further into the Caribbean, may pose an issue. Here's the present steering flow at the level that Irma is at. And so, as you can...
yeah, so there's the ridge in the Atlantic, which you can see. It's that kind of big bubble there that you can see here. That's your low. And then we've got a trough that's going to come down. You can see it pushing down. And so, at the moment, that's kind of holding it on its westerly trajectory, but that trough above is going to push down and weaken the western side of that ridge. And when the western side of that ridge gets weakened, that's when the course is going to change and it's going to tend to go poleward. But it's really hard to predict when that's going to happen. It's like two battling air masses, which one's going to win out. It could stay like this and not win out, and it could just stay going east, or you know, the ridge could completely win out and it just goes straight north, way off the coast of America, you know.
So again, you know, and as we've been watching this ridge, one thing that we have noticed is that since its forecast over the past couple of days and through now, it's been, well, moving further west than expected. And the other thing too is that it's been sort of strengthening a little bit more than what was originally anticipated. There's a bit of a lip that also sticks out here. And again, depending on how far south that this trough gets, or how weak this high gets, or vice versa, will really determine exactly sort of where that general track will be. Will it be off towards the west, or will it be off towards the west-northwest? So it's a ever-evolving situation, and we have to keep a very close eye on this. You know, I know that there's been a lot of talk, a lot of spread of long-term forecast models and so on that show big, massive hurricane over Florida or the East Coast or further in the Gulf. It's just simply too early to know exactly what sort of U.S. impact this will have. And you know, for right now, the impacts, the issues will be what Irma will be doing to the Caribbean islands. That's the main issue at the moment, is what is it going to do over these islands. And then when we get further and further into the islands, we worry about the other islands, but we also start worrying about the United States. But again, that is a good couple of days away before we start getting some good idea with that.
I'd just like to add to that, I mean, it's people in the US should be interested in the path, because obviously we know about, you know, when hurricanes hit land masses and weakens the storm, and so it's the path that Irma takes is going to depend on, end up making a difference, the strength of the hurricane and where it goes and stuff.
Mm-hmm.
So
yep. Indeed. So to help meteorologists, to help scientists figure out, well, where's the storm located now? How strong is it? And where is it going to go? We use multiple tools, including balloon radiosondes, surface observations, ship data, buoy data. But the other thing we also use is aircraft data. And there's various amounts of aircrafts that do the hurricane reconnaissance missions. Basically, we got 3 agencies that do these. We got the NOAA, the National Oceanic Atmospheric Administration. We have the United States Air Force Reserves, 53rd Weather Reconnaissance Squadron. We also have NASA's Weather Reconnaissance Operations. And so right now we have the NOAA and the U.S. Air Force doing reconnaissance missions into Irma. And I'll bring out here my aviation expert who will run down with you the different aircrafts that they do fly into the system. We got mainly 3 types of aircrafts: ones that do the low-level flying, ones that does the low to mid-level flying, and we got those that do the upper-level flying. So, Chris, will you go ahead and take it away with the aircraft that are presently flying out there?
Okay, well, we have 3 different types. And the first one I will start with is the C-130J. Most people do not know what a C-130J is. So, Adam, if you can put a picture up there for me, please.
Yeah, bringing it up.
Okay. What a C-130J is, it is a 4-engine turboprop military transport aircraft, which is, it could, as Adam says, it's one of the multiple aircraft that they use for doing hurricane runs. And why it is used for the hurricane runs, it has been re-engined so it has more power to punch through the eye wall and get the readings that they need.
And like, how much power is that? How much more souping up do you have to give that aircraft in order for it to have enough power to get through those ridiculous wind speeds of, what kind of wind speeds are you talking? Like the range of wind speeds that they fly through.
Okay, I'm looking on Wikipedia for this right now. And in mid-June 2008, the United States Air Force awarded a $417 million contract to Lockheed Martin for 6 modified KC-130Js aircraft.
Wow.
So, if that is saying anything, that is a lot of money going into these aircraft.
Well, it needs to be, I imagine, to get through that kind of battering.
That type of wind, yes.
Yeah.
Okay, Adam, if you will, put up the next aircraft.
So that aircraft, I know that the aircraft, before you change the picture, they all fly at different heights. Is that like a high flying thing? And why do they fly? Why is it important that they fly at different heights through the storm? Does it change the data that you get? Or like, why is that important?
Yes, it will change
this
the
one's
data.
A low level.
Yeah, this is a low level because she can get up minimum, or her maximum altitude most likely be 35,000 feet, which is where.
But for this particular aircraft, their usual flight range, and this is really low-level flying done by the crew here on this aircraft. They usually fly from anything from 700 feet up to about 5,000 feet. on an average run. So they're flying really far down, close to the surface.
So dangerous. Is that the most dangerous flight then? The lowest one, presumably, because you're getting buffeted around by the.
Yes,
wow.
That is the lowest.
Yeah. They also have, also Chris, if I could add in, there is a probe on the wing that they use for measuring surface winds based on how the sea looks. SFMR, was it stepped radiometer, rain gauge or something, wind gauge or something like that. And it basically measures down at the sea. It looks down at the sea and measures sort of the white caps and the winds that's coming off of that. And it's a very unique sort of instrument that they use to measure the winds down at the surface.
Mm-hmm.
Oh wow! So yeah, that's interesting because it's like the Beaumont scale that they used to use in the olden days to measure waves, you know, how many white caps are there and stuff. It's really interesting that we're doing that actually with technology now rather than our own eyes.
Yeah.
Because it's the same principle, essentially. Hasn't changed.
All right, we'll bring up the next aircraft, and this is definitely probably one of the most sophisticated instrumental aircraft with recon flying, and these guys usually fly from low to mid-level, so we're going about anywhere from about 1,000 to about up to as much as 20,000 feet, and that would be the P3.
Okay.
Have you got a picture of that one?
I'd just like to welcome our viewers to the live room chat. And we will get to your questions, comments, and with what's on the screen. This is coming from Adam on the Grand Cayman, along with Chris, who is our aviation expert. He is providing up-to-date information on what's happening. He is very knowledgeable when it comes to the aviation scene, and we have Lee over there in Scotland, for me David, east coast of Australia, and also Lucy also in Scotland. So apology for the background noise, but that's beyond our control at this point in time. So who would like to take over? Chris.
Yep. Yes. Yep. Okay. As Adam was saying, it is the Lockheed P3 Orion. It is a 4-engined turboprop aircraft, which its normal use would be for anti-submarine, but it also can be used for maritime and for weather. And it is a very distinctive aircraft. You'll know it when you see it. For the people that are in aviation or have ever were in the military or have done that type of stuff.
It's got a very weird tail sticking out of the back of it.
Yes. Yep. The aircraft is... Yeah, go ahead.
Yeah, just to mention the kind of odd shapes that do stick out, just to point out so people don't freak out here. What we do have with this specialized aircraft is special 3 radars on this aircraft that goes in, and you have a Doppler radar, a nose radar, and a belly radar, and all 3 of these radars check for different things inside of a storm. So again, here is your tail Doppler radar here in the back, your belly radar here in the front, and also your nose radar at front here as well. Also at the bottom there are slots for dropping dropsondes into the storm as well.
Can you just explain to me what a dropsonde is?
Okay, basically a dropsonde is an instrument that measures wind, temperature, humidity, every single thing inside of a storm. So as it falls down at the different levels of the atmosphere and drops down to the surface, it's measuring data. So again, you're not only getting a sort of flat 2D look at the system, you're getting a three-dimensional look at how the storm is evolving, how it's growing, how it's expanding. What's it doing? Why is the clouds doing that? Why is the winds doing that? And
so dropsons have been like a really important part of our advance in being able to like model and look at the inside of these storms and start to understand them.
Very much so. Yeah. All right, go on to Chris. The technical side of the P3.
Yes, I will give you some technical stuff here. Its natural role would be a maritime patrol aircraft. There are many users. There's a total of 757 ever built. The unit cost for this aircraft is $36 million.
Wow. I mean, yes. I know they need to be built to go in, but still, it's a lot of money.
Yeah, it is a very, very distinctive aircraft. I've had the pleasure of seeing them come here to Cayman. The Customs in the States has one. Homeland Security. Awesome looking aircraft. The cleanest one I've ever seen.
Yep, I've seen the Department of Homeland Security one.
Yes, that's the one I'm talking about.
Yeah, I've seen it up close and personal with that one as well, and it is a beauty. A little less blue and colorful than the NOAA's one here, but still very, very wonderful aircraft, nevertheless.
Yes.
Yeah, I commented on that when Adam first showed me the photograph of the plane before. I was like, what did they paint it that color for?
Yeah. I do want to mention something here about this particular aircraft. As a matter of fact, this very aircraft that you see on your screen is presently flying in Irma right at this moment. And this aircraft has very, very long years of history. This particular aircraft came out in the 70s and has flown many upon many hurricane hunting missions. And a matter of fact, in the 1980s, this aircraft was almost lost in a hurricane, Hurricane Hugo, when one of my, I call him my boss there at Weather Underground, Dr. Jeff Masters, he used to be the science officer on the aircraft at the time. And there was a moment when they were going through Hurricane Hugo where the de-icing flap on the propeller had sort of broken off, the engine caught fire, radars had went down for a period of time, and they were riding a very powerful hurricane, much like Irma, and they were literally limping in the eye wall. At the time, there was also the C-130 Hurricane Hunters flying in there, and they had to work together to try and get this aircraft out of the storm. A very limping aircraft, only flying on 2 engines, as a matter of fact. Lost engine number 4, and then I believe it was engine number 1, which, Chris, if you could correct me, engine number 4 is the one on the farthest to the right, and engine number 1 farthest to the left.
Yes.
And that was kind of lucky that it was balanced.
Oh yeah, and again, you know, flying through,
one on each side. Yeah,
and flying through a hurricane without all your engines, oh, that is some risky business, and they were luckily able to
yes, that is some serious business, that.
Yeah.
But if you do have the training, you can do it.
Yeah. And I just want to also mention that, you know, when you're flying through these hurricanes, technically you're not really flying straight through this thing where your nose is pointing into the storm. You're literally crabbing your way across the storm. And Chris, you probably know the term about planes crabbing along.
Yes.
Where they're literally flying almost diagonally, sideways in a storm.
Yes, because there is no aircraft built that most likely could punch through 185-mile-per-hour winds going direct. Even if you're coming at 500 miles an hour, you most likely would slow down and most likely stall.
Yeah. Yep. Okay, so a little enough of this aircraft. Let's move on.
So what height is this one at? Sorry. So the other one was the low level one. Is this like level, mid or
this
high?
This one does low to mid, so at times it does do low level missions, but its usual flying area is about 1,000 feet to about 1,500, where it usually flies. Depending on the mission that it does. At times it does do a little bit of both, but yeah, this one does it slightly bit higher than the other. So from here we go on to the next level of aircraft, which flies upper level missions. So the idea of this aircraft is to check the upper level environment, check the whole synoptic pattern out there. Where's the high? Where's the trough? Where's the wind flowing from? You know, what's the temperatures in the upper atmosphere? And this particular recon mission, most of the data in this recon mission gets put into forecast models and helps to make the forecasting a lot better. All the aircraft do, but this one in particular checks the whole synoptic scale around the system. So this aircraft doesn't necessarily fly in the storm. It flies around the surrounding areas, flies around the system, and at times fly above the system in specific patterns at very high levels to get that data and input that data into the models. And that aircraft is the Gulfstream 4.
So saying that, it sometimes flies above. How high do hurricanes usually go in the atmosphere?
Again, depending on hurricanes and the heights of the thunderstorms, it could get itself up from, you know, low, high level 35,000 all the way up to 60 odd thousand.
Wow, really?
And again, those are real cold cloud tops, as they're called, and they're very, very high up, and they usually produce the strongest thunderstorms. You usually see them.
That's what we see on, like, when you show the GOES radar, and we see those black blobs that kind of appear in the coloured imagery. No, we haven't got an example of that. That's a shame, but yeah.
But again, you know, you get these large, tall columns, and they're also called hot towers. And hot towers, in a developing hurricane or strengthening hurricane, usually mean the system is ramping up quite decently. And if you get a lot of these, you got yourself a very dangerous hurricane that you're dealing with. So, Chris, can you go ahead and give us the detail on this aircraft?
Okay, a Gulfstream 4.
That looks tiny. It doesn't look capable of flying for a hurricane.
I know, it's just a jet, but if anybody wants to, in the stream there, wants to give a guess at the service ceiling of this aircraft, and when we're done with the stream, I will answer that.
What do you mean by the service ceiling? Because I have no clue what
the service, the extreme altitude that this aircraft
how
can
high
go to.
Can it fly? Yeah. All right.
Yes, how high it can fly. Okay, so the cockpit crew will be 2, seating capacity of 14 to 19. Length is at 88 feet 4 inches. Wingspan is 77 feet. Overall height is 24 feet 5 inches. Her maximum takeoff weight is 73,200 pounds. Empty weight is 35,000 pounds. Her cruising speed is Mach 0.80 to 0.85.
Wow, really?
Yes. Her maximum speed is Mach 0.88. Her range is...
That's crazy. I can't get over that speed and that thrust as well.
Nautical miles. Yes. This aircraft can really go far. Her engines are Rolls-Royce Tay 600-8Cs, and they're rated at 13,850 static pounds of thrust each.
Whoa.
So,
again,
for such a small aircraft...
Yeah, the British like to go fast.
British built.
Yeah, the British like to go fast. We're good at our engines.
No, the Gulfstream is not British built.
No, the engine, the Rolls-Royce.
The engines are
yes, the Rolls-Royce Tays are built. There are 870 of them built. I don't know if I should even say this on the stream.
Maybe
but the price.
Wow. Well, we know all this. You know, we know military equipment. And to be fair, I'd rather they spend that amount of money on these planes because hurricanes kill a lot of people.
Yes.
And cause a lot of destruction, and the cost of, putting back the infrastructure and Katrina and, everything. It's a lot of money. I'd rather they spend money on this. I'd rather they spend more money on this than other stuff.
And the funny thing is that these three aircraft that we have talked about, play a very pivotal part to tell us where this storm is going to be and what it's doing.
Yeah, without these, we wouldn't even really
you wouldn't know where it is
on the track or where it is.
Okay.
Yeah.
With that in mind, the price for Gulfstream 450 is $41 million.
Whoa. I just can't think in those terms of money. It's like someone saying something abstract to me.
It's ridiculous,
it's
but
like
it is
pay me
necessary.
20,000 bananas. I can't imagine a pile of 20,000 bananas either. It's just
it is very necessary, but guess what? Once you do have that aircraft, it is an awesome aircraft.
Yeah.
Do you know if anybody, obviously there's tropical storms, hurricanes that go on in the tropics and obviously hit the Philippines a lot. Do they have aircrafts to monitor that?
I would not be surprised.
With that, I do have some information on that. There used to be provided by the U.S. Air Force operations in Guam. There used to be a hurricane hunting, or should I say typhoon hunting mission, a squadron down there. There was a mishap with one of their aircraft, which in the 70s occurred. Since then, it had been decommissioned. However, there is news that they will be recommissioning the Typhoon program, I believe sometime this year or next year. And there's also some chatter about getting a cyclone hunting program going for the Australian region as well, potentially in the near future.
I mean, the more information we can have, the more people can get out of the way of these storms. And this is what I find funny about America, is the government issues like a mandatory evacuation warning, and like people don't leave, and it's quite scary, I find, because like in Europe or the UK, for example, if that happened, like the military would go in and clear the area. Basically, people would have to leave. There's no choice. And yeah, it's really, really strange.
By the way, sorry, I have to bring this breaking news. The government of France has now changed the hurricane watch for the island of Guadeloupe to now a hurricane warning, as impacts to Guadeloupe is now expected to be of hurricane intensity within very short time from now as the hurricane progresses onwards. So again, the government of France has issued has upgraded their hurricane watch to hurricane warning for the island of Guadeloupe.
And if you look at the image, you can see some little luminous pink dots kind of under the storm there. Guadeloupe's kind of the top. Adam, if you can maybe show them roughly where Guadeloupe is.
Guadeloupe is located right here. And again, here is your system. I also want to point out here, whilst we do got this, that the eye of the system is actually not located where you see the satellite eye. Surprisingly enough, the hurricane is slightly, ever so slightly tilted, and the low-level eye, where the center of the core of the bottom of the storm is located slightly to the west on the western part of that eye wall, or southwestern part of that eye wall. So there's a little bit of slight decoupling kind of going on there, and not by much. Again, the decoupling is not likely to be drastic, and likely they'll all line up again once again. But it's interesting to take note that the actual center of that eye is located here, whilst the mid to upper level of that eye is out further towards the east. Anyway, this is still continuing off towards the west, and again would likely be making its direct impacts to the islands very shortly.
Hey Adam, while you're on that image, do you want to just tell everyone just what the colors mean?
Okay, so the colors on this image basically means the temperature of the clouds. So again, the higher you go up in the atmosphere with the clouds, the colder the cloud tops are and the brighter the color. Just to point out, I'll see if I could bring it up here.
So yeah, it's a bit counterintuitive, isn't it, when you first look at it? Because you first look at it and you think red, and you're used to seeing kind of red as a hot color. But in this case, you have to think of it as being very, very cold. And how cold are we talking? You know, that precious red. Are we
just
talking like really?
For the, there we go. So basically, I just put on the color scheme here. So again, we're seeing all of these sort of bright red. So we're talking almost negative 80 degrees in temperature, and that's very high up in the atmosphere that these clouds are. I do want to point out that yes, the colors are somewhat diminishing, and that's partly due to the diurnal factors that take place, sunrise, sunset, and how that changes the atmosphere, the surrounding atmosphere around the system, and this usually gives you daily cycles of increased and decreased thunderstorm activity. And this happens again every day. You got two different cycles, diurnal minimum and diurnal maximum. Diurnal minimums at sunset, diurnal maximums at sunrise. And so we have went through diurnal minimum as the sun passed over the system, and as you can see, the convective mass is, slightly coming down. As we go through the overnight, midnight onwards through sunrise, we would expect that these would blow up again, and you'd be going through another cycle of intensification through there. It's also going through a little bit of an eye wall replacement cycle. So basically what happens is inside the storm, you have that inner eye, and then you also have a newer outer eye starting to develop. What ends up happening, the inner eye collapses, the outer eye then shrinks and then takes over. So you do get these fluctuations with intensity with systems as well, and that also changes the heights of some of these convective cloud tops.
When you say like inner eye and outer eye, like what's actually happening in the storm there? What defines it? Is it just two bands of like different wind speeds, or is it?
Sort of, yes. So basically what happens here, and
you might want to pause it while you draw on it, because then it's
yes.
I'm trying to follow your circles across.
Okay, so just paused it here, and okay, so say, for example, you have your inner eye located right here, and then when you're looking at on radar, you also have sort of an outer eye that takes place along here. And so what ends up happening is that as the inner eye collapses and moves inwards to each other, as this thing resets itself. So again, your inner and then your outer eye. Draw it a little bit bigger so you can see it a little better. So as this moves inwards and collapses and falls into the center of the eye and just crumbles, the outer part takes in the pressure, and the pressure lowers further, and it all comes together.
And I was going to say, is that because there's a pressure difference? So is the pressure pushing in essentially from the outside, which is helping that collapse?
There's a slight pressure difference, but there's also a wind differences, intensity. That's why when you're looking at reconnaissance data, at times you could see where the winds increase due to the outer eye wall, then drop a little bit, then increase again. And when you go through the inner eye wall, and then just drop off completely when you get to the center of that eye.
Because that's really interesting. People talk about eyes and, you know, eye wall replacements all the time. You even hear them talk about it on the weather forecast, you know, when they're talking about hurricanes. But it's really interesting. No one ever sort of explains what that is exactly. We all know that there's a quiet center in the middle of a hurricane. You know, you're kind of taught that at school, but they never go into sort of why.
Yeah.
Lull.
Yeah. So, you know, and again, I do want to point out, again, for people who don't know or don't realize, the strongest part of the winds will be found in that eye wall, but more so on the northeastern quadrant of the storm. So this is where you usually find the strongest of winds. And again, usually, although there are times when you get a very strong system, much like this, and you do tend to have sort of a donut shape in that eye where the strongest of winds tend to be. So within this area here, around here, this is where the strongest of those winds would be. And again, with that stronger of winds, that's why occurring down here as well, this is why the government of France had upgraded that as well for the island of Guadeloupe here, as they are expecting that to happen.
So the strongest winds, you said, always on the northeast side of
for
the eye
the
wall.
most part.
Is
for
that
the most part?
Is that the opposite on the other side of the equator?
Because
the storm's like moving a different way, or is that it doesn't matter?
It's the other side.
There, I would think so. Again, I'm not so much of a cyclone expert, even though it's pretty much the same thing. Let's see where the winds.
Lucy's actually right. Yeah, that is the opposite, the other side of the world.
Okay.
Right, carry on.
Good. Yeah. So.
Just to clarify, because there's lots of different names, hurricanes here, and then we talked about typhoons earlier and cyclones. They're essentially the same thing, right? They're just called
they're essentially the same thing. Yeah, same thing, just different locations, and there is also a slight difference with intensity. Again, you know, they over in the Western Pacific call a Cat 3 what we essentially call a Cat 2. You know,
so there's a few differences.
So there's differences between the different intensities, but again, overall, hurricanes are for Atlantic, Eastern Pacific, Central Pacific, typhoons in the Western Pacific, and across the Chinese seas, and there in those areas, Sea of Japan, all of that area, and
around the cyclones.
Yeah, in the southern hemisphere, pretty much going right around the world on the southern hemisphere, they're called cyclones. In the Indian Ocean, they're also called cyclones. And on the rare few occasions that had happened in the South Atlantic, and I mean, they're very rare, but becoming less rare over the past couple of years, though. We have been seeing them in the South Atlantic. They're called tropical storms. There's only been one that's really been considered as a hurricane, which is Hurricane Katrina back in 2004. springtime 2004, should say Northern Hemisphere spring, um, late spring, should I say, that occurred and made landfall in Brazil as a Category 2 hurricane, actually. So, but anyway, that was the only known time of a hurricane force system down there. And again, it is sort of rare to get these tropical systems there, as conditions are not as favorable as other areas, and the tight spaces between South America and Africa doesn't really leave a lot of room for development of tropical systems.
Okay, with the warning coverage until further notice, currently on the screen is one of the NOAA floaters on Irma. Adam, it looks like it might have changed course slightly to possibly a west-northwest, just looking at the eye. Perhaps you might be able to give us an update on the location and possible tracks. You got any other information you can bring up?
I will have a little bit more in just a second here, David, but one thing that I will say again is that based on reconnaissance data, the latest advisory from the National Hurricane Center, the actual center of the system, the actual center part of the eye, is actually located on the southwestern side of where the eye that you see on the satellite imagery is. And the present movement is still off towards the west, maybe slightly north of the U.S., but still in that general westward direction. I just want to look through the hurricane reconnaissance data to confirm and see what they are saying in terms of that.
Yeah, have they landed already then? Are they back now?
There's a few aircraft flying in there. There's the Air Force and NOAA aircraft flying into the system. And I'll be right back in just a second.
Coming on the screen is a look at one of the local, I think it's the Guadalupe Martins radar, and you can definitely see Hurricane Irma still maintaining a very healthy eye, and I'm not sure how many eye wall replacements it has undertaken. This is a Cayman Hurricane Center rolling coverage, and back to Adam.
Right. Thank you, David. Yes, so just to cover over what David was saying, yes, this system has indeed went through many eye wall replacement cycles. Actually, I am indeed impressed by the amount of eye wall replacement cycles that this thing has taken, and the fact that this thing was able to intensify to the way that it has, and able to maintain that intensity through those eye wall replacement cycles are very much impressive in itself. And looking through Hurricane Hunter data, it's still off towards the west, maybe slightly due north of west, but overall still off towards the west. The eye wall, the upper part of the eye wall, again slightly displaced, but other than that, there's nothing much that really has changed. The pressure readings, again, more or less the same as advisory, 916, 917 thereabout, and yeah, so it's still going. Recon, both Air Force C-130 and the NOAA 42 P-3 aircraft, the same one that I showed you the image of just a little while ago.
And where will they fly through the storm? Like, if you were going to kind of draw their track on there, like, so, where would they go?
Yeah, definitely. Okay, so this is what the general. Here we go again. Okay, so
just get it on the last point and then just pause it. That's probably what I'd do.
Okay, so the general flight pattern is an X profile. So basically, the Air Force, they're based out of their forward operating base in St. Croix, which they'll all be evacuating throughout the evening and should be pretty much finishing off with that. But basically, their flight pattern is as such that they sort of come up through the system and then make an X pattern through the storm, getting through the eye wall and through the eye as much as possible. And sometimes they do a sort of star pattern through system, and they basically go through the eye a few times, 4 or 5 times, maybe even up to 6 or 7 times, and they fly through and they examine pretty much all quadrants of the system and tracking the eye as it moves throughout its pattern. So generally, that is.
Do you know how often the measurements are taken? Are they taken like every minute or every 30 minutes? Or
they do observational stuff like every minute or so. But in terms of drops on data and so on, it's
is that based on like the level, or how many drops ons do they put in? Like, how big are they?
It depends on the particular mission. I do believe the Air Force One that is flying has dropped, I think it's about 2 so far. One on the northwest side and one in the core. They'll be dropping another one. Again, one of their drop zones is what they call the vortex message, or basically the data message for the eye. And so what they'll eventually do is that main areas of points that they're going to be taking is the 4 quadrants of the system. So northwest, south, east, northeast, southwest, but also inside the core of the system as well.
And so presumably when they drop these things in to the hurricanes, they are spinning around, are they, with the winds
throughout the evening,
and they're tracking them? Is that what they're doing? Or are they are they their own data little bundle that's sending data back to the aircraft?
They have their own bundles of data that, again, if you look at it from a top-down, or should I say, a side profile view. So here's your storm, and so they drop their drop zones, and as it travels down, obviously with the different levels of the atmosphere, high, mid, low, it will move around, and the data will be going into this. It'll figure out where in the different levels of the atmosphere is the winds turning, how is this affecting the system, how much dry air is getting into a particular area, how much moisture is getting into an area, what's the temperatures, and so on and so forth. There are also special drop zones that after they leave the aircraft and after they drop through the atmosphere, they also have special buoy drop zones that even drops subsurface and actually measures the temperature, the surface of the water and subsurface temperatures of the waters below the system.
And and we know that's really important, right? Because the water surface temperature is really important in terms of the development of hurricanes.
Yeah, the surface and subsurface temperatures are definitely helpful to determining on how strong this thing will get and how that is interacting with the system at present.
So is like the general rule, the warmer the sort of temperature, the more energy it gives it? Or?
Yes. The other thing that I wanted to point out, and I will also be going on to the other systems here, but just to point out, I'm going to use this other chart here, or the other map I have here. And there is the other aircraft, as we've mentioned, the Gulfstream aircraft that does that up-level mission. And basically what that aircraft is doing, and I'll use the current mission that it had flown. So again, their forward operating area is Barbados. So what this aircraft has done has flown off away from the system, fly up to the north, sampling the air masses up here, and trying to find out, okay, where is that weakness? How is the high pressure ridge doing? How is this affecting the system? And they also fly around the system as well for ending up back into Barbados. And so they're measuring the air around the system, they're measuring the air to the north and to the west of this system. And so this data will go into the forecast models and help to provide a better idea with the intensity, as well as especially more so the forecast track for the system.
And of course, that's what we all want to know, don't we? And that helps us save more people, get more people out of the way of storms, is if we can forecast where they're going better and improve that forecasting, then more people will be able to evacuate when they know a storm is coming, a hurricane is coming.
So as I do have this up here, I might as well do mention that Irma is not the only troublemaker we have out there in the Atlantic. A matter of fact, we have a couple of other systems that we will need to be keeping a close eye on. Again, guys, we are in the active part of the Atlantic hurricane season, and nowhere is safe from these systems developing out in the Atlantic. So everyone needs to keep a close eye on everything that goes on out in the Atlantic. And again, come and check us, and we'll keep you up to date on whatever threats may be out there looming. So
when you say hurricane season, when is the hurricane season?
Okay, so hurricane season usually goes from June 1st to November 30th. However, you can have storms outside that that timeline. You know, as we've seen this year, our first named storm, Arlene, which formed out here in the Atlantic in April, sort of spun around out here for a bit, and and even as much as last year when we had Hurricane Alex, a January hurricane, which came across up here in the northern Atlantic. And we've had several times where we had storms in December. We've had pretty much a few storms throughout almost every month of the year. I think there's only one month that has had the least amount, and I believe that would be March.
So, but am I right in saying, like, the season, do you typically see the stronger storms within the hurricane season?
Again, where you see the most activity would generally be June to November. However, as the years have gone by, it seems to have changed now more with May and, say, December. So, and there has been some chatter about maybe the possibility of expanding out the season's timeline out to that much. Again, there's plenty of discussions on stuff that could be improved on to help make things better with the forecast.
Well, I guess it makes sense because our seasons are changing on Earth, so obviously our seasons will probably also change in our atmosphere.
But anyway, to get on to the other systems here, we have ourselves Tropical Storm Jose out here, gaining strength in the central tropical Atlantic here. It is moving. It is moving off towards the west, which is interesting. Earlier it was moving west-northwest. Now it has changed towards the west. And the forecast track for that has shifted a little bit off towards the west ever so slightly, but again, the forecast cone for that more or less takes it towards the islands, and potentially maybe lifting up north. Again, there's a lot of things that will need to take place, and again, not really too worried about the islands just yet. 5 days out, again, we'll see what happens during the day 3 period. A lot of things can happen, and we're looking at how Irma may affect how Jose moves and intensifies. There's a lot of things that will go on.
How would Irma? So you said Irma's going to possibly affect the way Jose
again, Irma is a fairly decent system. Jose is a fairly large system as well. And there was some chatter about maybe potential for what's called the Fujiwara effect, which is sort of storms doing dances around each other. So they sort of interact with each other, and how they move, changes the stirring flow around the system. So, for example, you got the flow around the storm like so, going as such around Irma. You also got Jose that's doing a similar sort of thing here, there and there. And so what could potentially happen is, as Irma moves off into that direction, Jose may take a more northerly track around the system.
Because the air masses are moving in kind of opposite directions there, aren't they, against each other? So it's going to push it off like spinning tops, I guess, or spinning coils or something.
Sort of like spinning tops. But again, there's a lot of distance between Irma and Jose still. So again, depending on what Irma does will affect. But one thing that seems to be the case, and as we've looked through model guidance over the past couple of days, as this was a tropical disturbance before, and they've been running models on it, but the trend on that has been shifting a bit further south and west on that. So maybe there won't be as much interaction as originally thought. Again, plenty of time to watch. Again, Jose is 5 days or a little bit more away from any sort of landmass, so not really concentrating too much on that at the moment. There is also Tropical Depression 13, which is expected to become Tropical Storm Katia. And this is going to be a bit of a concern, as we all should remember. Just very recently, we've had a very dangerous Hurricane Harvey come into Texas, come off and make landfall in Louisiana, causing a whole lot of devastation, damage, especially related to water in these areas. Really completely devastated quite a few areas there in eastern Texas and parts of Louisiana. I'm sure Lucy could run lists and books on the amount of stuff that's gone on through that area. But the new area of concern now is 13, and again, same sort of general area. In terms of its forecast track, it's a bit unknown. It's sort of supposed to, at least for now, meander around through the Gulf of Mexico here, doing something. We're not entirely sure exactly where it will end up going, but it's going to be here for a good while. And
yeah, the models show it kind of doing a loop-de-loop, don't they? Just kind of there.
Yes. And with that being said, this thing will intensify, and there is even the potential that this thing could intensify up to hurricane intensity. Of course, we're not really expecting to see as much as, say, Harvey, as Harvey did upwell some of the waters up along this area here. And so, again, it'll have to be watched closely. If this thing pulls further northeast and get into the waters more into this region, it may be more of a concern. Again, that is a couple of days away to go. There's a lot of things that could happen. But one thing that seems clear is that, well, 113 is fairly large in terms of, the thunderstorm area and so on. And rainfall, again, may be another issue for Texas and Louisiana, parts of the Gulf of Mexico, the Yucatan, the Bay of Campeche, Veracruz, Mexico, all these areas here. So there might be issues there with regards to rainfall and flooding.
And that's really bad news for the people at the moment in Texas. So we need to keep a really close eye on this one, because everybody's trying to sort of rebuild their houses, and the rivers are only just finally beginning to recede and the water go down. And obviously everybody knows they're still releasing water from the dams, and that's why they're releasing water from the dams and still flooding homes in downtown Houston, because they know that 13 is in the Gulf of Mexico, and they want to make sure that they have enough space to deal with the rainfall. So, and this is why, and I know people are very upset because they've flooded their homes for a second time after it went down, but they need to understand that it's very important that they do that, and those dams are doing the job that they need to be doing. So
yes. So again, it's a very sad and trying times for the northwestern Gulf and central Gulf Coast with what happened there. And it is quite saddening that, again, we have another system out there that could potentially produce more rainfall to the affected areas. And again, this will impact obviously on how much more flooding will occur, but this will also, and I'm quite sure Lucy will agree with me, this will affect on how the search and rescue and recovery missions go. This will affect
the aid,
on how the
aid
assessment
gets in.
How
There's
the assessment process. Yes.
That they're having to take food in, like the communities are high and dry, but the roads are not, and they've only just gone down enough to be drivable, like by trucks. People have been having to boat like basic supplies into especially the rural communities just to keep them going. So yeah, this is not great news, but hopefully, like you said, it's predicted track, and the water is definitely not as warm there after Harvey going over it. So the good news is there's nowhere near as much energy in that area. So there's some positives, but yeah, it's not great.
Yes.
Okay.
All right, so that pretty much more or less covers what's gone on. I don't know if anyone else wants to add anything. What I will want to mention is that for areas, we're going back to Irma here for a moment here. For areas in the Eastern Caribbean islands, the northern Leeward Islands, you guys should still remain hunkered down, stay safe, stay secure, try not to leave your place if the eye is passing over your area. Be warned, the calm is not the end. You still would have the back end of the system to contend with. So again, remain in your places until the all clear is given. For you guys in Puerto Rico and the eastern part of the Virgin Islands, if you have not finished your prep or you're just about done, please rush them to completion and get hunkered down. This is a very dangerous hurricane, a very dangerous situation here, and it is a power not to mess with. For you guys there in the Dominican Republic and Haiti, you guys know what we're talking about, especially you guys in Haiti. You've been through last year with Hurricane Matthew. You know what a Cat 5 can do. So you guys get yourselves hunkered down, prepare the best way you can, and do whatever needs to be done to make sure that your lives, your family's lives, and your property is as secure as it can be. And when time comes, do not hang around. Get yourself safe. Get yourself indoors. Protect yourselves. Protect your family. For you guys in the Bahamas and Cuba, keep a very close eye on this system, as well as you guys there in Jamaica. Northern Jamaica may, depending on how the system goes, you may see some effects, whether it will be the outer bands and you guys get the northerly wind flow as well as some of the higher surfs on the north and west coast, or you guys get much more of this system and you're getting rain and potentially tropical storm conditions. At the moment, not exactly seeing that just right now. However, again, the forecast can very easily change, as I've pointed out with some of these model guidances on the reliable models that are showing as such. For you guys there in the Cayman Islands, also keep a close eye on the situation. I do know that the National Weather Service of the Cayman Islands has mentioned that they are keeping an eye on it. They are expecting conditions over the weekend to deteriorate somewhat, and depending on how much will really determine on what warnings will be provided for us likely later during the week. So that should be kept very close eye on. You guys in Florida and the rest of the Bahamas also get yourselves prepped up just in case this thing takes a more easterly track. Chris, if you're still there, would you want to just quickly mention how
Chris
just in case? Oh, he's stepped out. Oh, well.
What I would like to say, apology for cutting in. Welcome to Hillbilly, zombie expert on the chat. Currently on the screen is the latest track from the National Hurricane Center. Adam, if you'd like to have a look at the latest information from the NHC, I think there might have been a update. I've just refreshed the page, and whilst we have the track on the screen, that'll give you a little bit of time to see if the picture has changed. So, Lee,
right, yes.
Go on, Adam.
Yeah, at the moment, there hasn't really been any sort of major changes. Nothing's really changed much. Again, we'll be keeping an eye on the situation as it goes forward. Again, the idea with model data, and I want to get people clear on this. Models, they flip-flop every which way with every run. The idea is getting the consensus, getting how the models evolve over several days and so on. So it's something that will need to be watched over time. So I wouldn't really concern ourselves with a particular model run on a particular day, but really the consensus of models over an extended period of time. Again, don't worry about it so much for long range. Just right now, just keep an eye on the 2 to 3 day forecast. We'll start to work on the later editions of the runs as we go forward in time.
And what do you think about storm force wind probabilities? What areas are going to start to fill Irma's
presence?
Okay.
Yes.
Well, if I still have the screen here, again, this is from the National Hurricane Center, the most likely arrival time for tropical storm force winds. So you can see a fairly large area marked out here. Again, I'm not too worried for the time being about, over the weekend, late weekend, going into early week for now. But for the islands, again, the eastern part of the northern Lesser Antilles, the Leeward Islands, would be starting to get that effect from now, going through the overnight hours into tomorrow. Again, starting to spread through areas such as Puerto Rico throughout Wednesday. And as you could see, impacts possibly to Bahamas or Hispaniola through Thursday. And then possibly Central Bahamas, Cuba, Oregon, Jamaica through Friday. And then through the overnight Friday going through to Saturday, potentially the northwestern Bahamas all the way down to the Cayman region. And then beyond that, well, we'll see where things go. So this is, again, the most likely time of arrival for tropical storm force winds for the whole entire area here. And again, it's really dependent on where the track of the storm really takes place. Again, if it takes place further south, these areas down here will feel it more. If it goes further north, these areas will feel it more. So we'll see how things play out.
I think Chris is back.
Yes. So just want to mention, people are going to start looking about evacuating these islands through these areas here, and there's going to be people wanting to evacuate to other places to get out of the storm. Just using here for example, say that the storm does indeed take that more southerly track and come through the Caribbean here and head towards here, or even come across through here. Chris, would you kindly just run through, for example, here how airport operations go, say from we get the tropical storm watches through till we get the hurricane warnings, and how airport operations progress going through that timeline, and even before the watches and warnings are issued.
Okay, well, if we get any information of a viable hurricane coming through, what we try to do is try to get the tourists off island first, which would be the most safest thing to do, because you don't want to have to put them up here. Just tell them that, hey, we got a hurricane coming, saying, hey, if you want to come back after the hurricane's gone across us, so be it. But as Adam was saying, if we have it coming down to more closer to Cayman, you'd want to get all people that want to go off island off and get them somewhere out of the way of the hurricane. So once we get that viable threat and it's coming into our area, they will, as most of you know, with Hurricane Ivan, what happened? They got all the tourists off, got all the aircraft that could get out of here to other locations, out of the way. And I know this as a fact, and I'm not really at liberty to say what Cayman Airways did, but their aircraft, all I will say is that their aircraft were flown out. That's all I'll say.
It's so how long can you operate? Like, what are the winds like that would shut down like a passenger airport? Like, how close would the like air traffic controllers people like
our
leave
maximum
it?
crosswinds? Our maximum crosswinds that some of the aircraft I've heard that we have can take are 32 miles per hour.
Yeah, but they would never do that, would they? With full load of passengers,
No.
Probably they wouldn't do the maximum.
No, they wouldn't even risk it.
Yeah. So what do you reckon they'd kind of stop at a guesstimate? Because with like commercial like airline, just because it's interesting thing to know as a person traveling around the world on holiday, like.
Yeah. Well, within their safety margins from about 20 to 24, maybe they would take the risks.
Yeah.
But anything above that, they would not. And as we see here on the screen, that hurricane.
And where would we see the wind, those kind of winds on that hurricane? So, like, in other words, how far away from the island does it have to be before it will shut down the airport?
It could almost. What's the diameter of the storm? How many
Yeah, I was
miles
going to say
across?
it's probably. Sorry, that's probably a very hard question.
Okay, so for example, using Irma here, Irma's wind field is let me just double check here, is at come on here, 175 miles.
So that's all the way across, right?
That is
No,
from
here.
That is from the center to the outermost tropical storm force winds.
Right. Okay. Yeah.
So if you want to know the whole entire sort of diameter, you gotta take that 175 and just double it onto the other side.
Okay. So.
Yeah.
So, but we only need that measurement, don't we, to work out? Yeah.
Yeah, we don't need that whole measurement. So 175 and 175, is that times or just straight up adding?
Just add it.
Well, it doesn't matter because the strongest winds are on the inside and the lightest winds are on the outside. So if you're talking about something coming towards it, it's only sort of the first half of the storm because we're talking about when it will close. So when's your last chance to fly out, I guess? Yeah.
350 miles. From here to Jamaica is just over 200. So you don't want that thing within 350 miles.
Wow. Yeah. Okay. So that's yeah. I mean, it's not a long way, but it's quite a long way all the same. Yeah.
Yeah. And what speed is she moving?
She is moving at 15. I'll double check on that. That is indeed correct. West at 15 miles per hour.
15 miles per hour. So she's not quick. They're not quick. Then
again, 15 miles per hour on a hurricane, especially this kind of a hurricane.
That's pretty quick.
It's quite fast. Again, we've had hurricanes that have traveled. I remember hearing about I think it was Chris. What was it, Gilbert or Mitch, that literally almost stalled out in the Western Caribbean, only moving at about 1 or 2 miles per hour.
Yes. I remember.
So similar to what happened then in Houston when Harvey stalled out, kind of very slow. I mean, Harvey really stopped, but
really stalled out.
Yeah, Harvey literally stalled out over Texas.
Yeah, but then again, for this hurricane, again, 15, anywhere from 10 to 20 miles per hour is considered your average decent speed that a hurricane usually travels at. There has been, like, for example, I remember Hurricane Dean in 2007 had traveled across the Caribbean at some 17 miles per hour. It was one fast system. It was literally Usain Bolt going across the Caribbean.
at 17 miles an hour. Woo!
Yeah.
Go storm. Yeah.
Yeah. So and of
but
course
that's top of the pops for hurricanes.
And again, especially for down this way, usually the higher in latitude you go, the faster things can get. I mean, I remember seeing a few hurricanes, couple of storms that were moving at the speed that it will almost match the wind speeds. I've seen 45 mile per hour tropical storms moving at 45 miles per hour off to the northeast. I've seen hurricanes moving pretty much 75 miles per hour up to the northeastern Atlantic, eventually getting absorbed into a non-tropical system. But yeah,
So there is
but for
a big
down
range of speeds then. Yeah.
Yeah, but for down this latitude down here in the Caribbean, 15 anywhere from about 14 to 18 miles per hour is considered quite fast.
Yeah, and you don't want anything like that anywhere near the airport because wind shear. You don't want anything like that to happen when you're having aircraft trying to leave the island.
So, you know, when they shut the airport and say, I'm sorry, the last flight is gone, they're doing you a favour, really. You don't want to be in an aeroplane during a hurricane.
I mean, imagine... You could even see, you know, some of the flights across the UK when you get that crosswinds going across those runways, and you see those aircraft just really bouncing up and down, touch and goes on runways, have to do a go around, and it's some scary stuff. But
yeah, there's loads
of
YouTube clips, isn't there, of that?
Yes.
Again,
especially out at Heathrow too.
Yeah.
And again, you know, with this, I mean, that's just, you know, your regular heavy winds. You're going to get double, if not triple times worse than that in a hurricane. So you do not want any aircrafts, any aircrafts whatsoever in or around those areas, especially the small private commuters, the private jets, helicopters. They
especially helicopters, Cessnas. No, definite no-nos.
Yeah.
Yeah, and I imagine if you were quite rich and you had the means and you had a plane, it would be quite tempting to try and get in it and get out.
I think there are some international regulations about flying into stuff like this.
Yeah.
I don't think they would want you to be flying into 185.
Yeah, but you know, kind of very rich people and rules. Like,
Adam, I'll need to jump in a wee minute.
Yes, definitely.
David's looking to go down to the chemist. He's wanting to know what you're wanting to do.
Well,
you want to end this stream or what?
You know, pretty much we covered as much as we can for the time being.
For 2 hours, so.
Yeah, so what we'll do is that we will pause the stream here. We may continue a little later on, if not tomorrow, especially going on through tomorrow and the day after. We'll see what we can do about assessing what has occurred over the islands, or what is occurring over the islands as Irma moves through, and we'll continue looking at where Irma will go as we go further onwards. So I think, yes, indeed, for the time being, we will pause for now, and we'll continue this at a later time.
Right. There you are, David.
Okay. Well, as Adam has said, we'll continue to bring updated information, and bye for now.
Yeah.